Hello everyone. Today we're diving into one of the most intriguing mysteries of 20th century astronomy. Even before the launch of the first artificial satellite, a research project at the Palomar Observatory detected strange phenomena in the sky. Objects that appeared and disappeared inexplicably. What were these transients? Nuclear tests leaving traces in the atmosphere? Or something more extraordinary? Unidentified anomalous phenomena, the famous UAPs. Let's explore this fascinating story using real scientific data. To fully understand this mystery, we need to go back to the late 1940s. The Palomar Observatory, located in the mountains of San Diego, California, was one of the most advanced astronomical centers in the world. Equipped with the then revolutionary 200-inch Hale telescope, it represented the pinnacle of observational astronomy technology at the time. Between 1949 and 1957, the observatory carried out an ambitious project known as the POSS, the Palomar Observatory Sky Survey. Its goal was monumental: to create a systematic photographic mapping of the entire visible sky of the Northern Hemisphere. Night after night, astronomers pointed the massive telescope at different regions of the sky, capturing images on sensitive photographic plates. This was not just an exercise in cataloging. The POSS provided a permanent record of the sky, allowing astronomers to identify changes over time, discover new objects, and study the distribution of galaxies across the universe. The resulting photographic plates would become a reference for decades, consulted by generations of researchers. Here is a critically important detail for our story. The POSS project concluded in April 1957. Humanity's first artificial satellite, Sputnik 1, was launched by the Soviet Union in October 1957. This 6-month temporal distinction is crucial. Why does this matter so much? In the modern era, transient phenomena in the sky are often caused by artificial satellites. A satellite crossing the field of view during a photographic exposure appears as a streak or point that is absent in subsequent images. It's a perfectly explainable transient, a human-made object moving in orbit. But throughout the entire POSS period, there was not a single artificial satellite in space. The sky was completely free of human-made orbital objects. Any transient phenomenon detected during this time could not be attributed to satellites. This absence of satellites makes the POSS transients particularly intriguing and mysterious. Before we proceed, we need to clearly define what we mean by a transient phenomenon in an astronomical context. A transient is any celestial object or event that appears briefly and then disappears, or one that changes significantly in brightness over short timescales. Imagine two photographs of the same region of the sky, taken 50 minutes apart. In the first image, you see 3 bright points that look like stars. In the second image, those 3 points have simply vanished. They are gone completely. This is a classic transient phenomenon. In modern astronomy, we know several types of genuine transients. Supernovae are the most spectacular example. Massive stars that explode catastrophically, increasing their brightness by billions of times over a few days or weeks before gradually fading. Novae are less dramatic explosions in binary star systems. There are also gravitational microlensing events, where massive objects pass in front of distant stars, temporarily amplifying their brightness. But the POSS transients were different. They appeared and disappeared on very short timescales, sometimes just minutes between observations. Supernovae do not behave this way. No known natural astronomical phenomenon could account for objects that appear and vanish so rapidly. When modern researchers began systematically examining the old POSS photographic plates using digital analysis techniques, they made a surprising discovery. Multiple instances of objects appeared in one exposure, but were absent in subsequent exposures of the same region of the sky. These were not obvious artifacts or defects on the plates. The objects looked consistent with real point sources, indistinguishable from faint stars in the images. Yet their behavior was completely anomalous. Stars do not vanish in just 50 minutes. The initial cataloging identified dozens of these transient events over the 8 years of the POSS project. Each case was carefully documented with precise celestial coordinates, the exact time of observation, and the photometric characteristics of the transient object recorded. With this database in hand, modern researchers began searching for explanations. The first step was to rule out the obvious causes. Gamma-ray bursts. No, the duration and spectral characteristics did not match. Asteroids reflecting sunlight. Impossible. The orbital motions would not align with the observations. Some kind of systematic defect in the photographic plates or processing. Extensive testing ruled out this possibility. Having ruled out conventional astronomical explanations, researchers turned to a darker, more terrestrial possibility: nuclear weapons testing. The period from 1949 to 1957 coincided precisely with the peak of atmospheric nuclear tests conducted by emerging nuclear powers, the United States and the Soviet Union. During this era, hundreds of nuclear devices were detonated in the atmosphere and at the surface. Each detonation released colossal amounts of energy, creating intensely luminous fireballs. launching radioactive debris into the stratosphere and disturbing the atmosphere in complex ways. One hypothesis was that the intense radiation could produce transient luminous phenomena through various mechanisms. Cherenkov radiation, for example, occurs when charged particles move through a medium faster than the speed of light in that medium, creating a characteristic bluish glow. High-energy particles from nuclear explosions could, in theory, produce visible Cherenkov-like effects in the upper atmosphere. Another possibility was direct ionization of the upper atmosphere. The intense ultraviolet and X-ray radiation from a nuclear explosion could temporarily ionize vast regions of the atmosphere, creating luminous plasma that might appear as bright points or flashes. There was also the more mundane possibility of radioactive contamination affecting the photographic plates themselves. Radioactive materials dispersed in the atmosphere could eventually settle at the observatory, exposing the plates and creating artifacts that resembled genuine point sources. To test the nuclear hypothesis, researchers conducted a sophisticated statistical analysis. They compiled detailed data on all known nuclear tests during 1949-1957, including exact dates, locations, and explosive yields. They then compared the temporal occurrence of POS transients with the dates of these nuclear tests. The results were statistically significant and intriguing. Transients were 45% more likely to be observed on dates within a nuclear test window, defined as 1 day before or 1 day after a known test, compared to dates outside this window. This 45% correlation was already notable, but an even stronger pattern emerged upon closer inspection. When researchers focused specifically on observations made exactly 1 day after a nuclear test, the probability of detecting a transient jumped dramatically to 68%. This peak in occurrence exactly 1 day post-explosion is highly significant. It essentially rules out direct contamination of the photographic plates, which would not show such a precise temporal dependence. If radioactivity were simply staining the plates randomly, we would expect a more uniform distribution, not a sharp peak, exactly 24 hours after the tests. The timing also argues against debris ejected directly from the explosions as the cause. Material lofted into the stratosphere by a nuclear detonation would not produce such a precise 1 day after pattern. Atmospheric dynamics are far more complex and variable. Now we come to the part many consider both fascinating and controversial. Researchers also investigated a possible correlation between POS transients and historical reports of UAPs. Unidentified anomalous phenomena, the modern and more scientific term for what were traditionally called UFOs. The period 1949-1957 coincided with what many ufologists call the golden age of UFO sightings in the United States. Thousands of civilian and military reports documented unexplained aerial objects, including well-documented cases with multiple witnesses and even radar confirmation. Researchers compiled a database of UAP reports during the POS period, focusing specifically on the most reliable cases, those with multiple independent witnesses, official documentation, or other corroborating evidence. They then looked for statistical correlations between the dates of these UAP reports and the dates of transients observed on POS plates. The results were surprising. On days when at least one transient was identified on a POS plate, there was a statistically significant, albeit modest, association between the total number of transients and the number of UAP reports. More advanced statistical models revealed that for each additional UAP report on a given date, the number of transients observed by POS increased by 8.5% on that same date. While this correlation is not extremely strong, it is statistically significant, unlikely to be purely coincidental. A particularly intriguing example highlighted in the study involves the famous UAP incidents over Washington, D.C. in July 1952. Over several consecutive nights, multiple unidentified objects were detected on radar and observed visually by air traffic controllers, military and commercial pilots, and numerous ground witnesses. These events generated massive public attention and prompted an official investigation by the Air Force. The Washington case remains one of the most well-documented UAP incidents in history. Fascinatingly, POS plates from the same period showed unusual transients, suggesting a potential correlation between the phenomena. It is crucial to emphasize that correlation does not imply causation. The simultaneous occurrence of UAP reports and astronomical transients does not necessarily prove that they are the same phenomenon. Other unidentified confounding variables could be influencing both sets of observations. This is where the analysis becomes truly fascinating. The researchers did not limit themselves to examining the nuclear and UAP hypotheses separately. They also investigated what happened when both factors were present simultaneously. Dates that had at least one UAP report and fell within the nuclear test window showed the highest total number of transients of all. The effect was more than additive. There appeared to be a possible synergy between the two factors. This finding raises intriguing questions. Could there be some physical connection between nuclear tests and UAP phenomena? Some speculative theories suggest that advanced civilizations might monitor our development of nuclear weapons, increasing activity during test periods. This is, of course, a highly speculative idea, but the statistical data at least do not completely contradict it. It's important to emphasize what the researchers were able to rule out. Defects in the photographic plates were extensively tested and eliminated as the primary explanation. Observer bias, the human tendency to perceive patterns where none exist, was minimized through objective computational analysis of the plates. Optical artifacts from the telescope were characterized and did not match the transients observed. Internal reflections, dust on the optics, and other common instrumental issues were systematically ruled out. What remains are genuine phenomena captured on the images, whose physical nature remains uncertain. They were real in the sense that they truly exposed the photographic plates. The question is, what exactly were they? After decades of analysis, multiple peer-reviewed studies, and investigations into numerous hypotheses, we still do not have a definitive answer regarding the nature of the POSS transients. This honesty about uncertainty is, in fact, a strength of the scientific approach. Science does not demand immediate answers to everything. It is perfectly acceptable, even expected, to say, "We don't know, but we continue investigating." The Palomar transients represent a genuine, unresolved scientific mystery. Statistical evidence points to intriguing connections with nuclear tests and possibly with UAP phenomena, but these correlations do not provide a complete mechanistic explanation. We do not know exactly how nuclear detonations might produce the observed transients, if indeed they do. And we certainly do not know what UAPs truly are, let alone how they could be related to these transients. What can we conclude from this fascinating story? First, that the universe, and even our own atmosphere and near-Earth environment, still holds genuine mysteries. Second, that rigorous scientific investigation of these mysteries is valuable, even when it doesn't produce immediate, definitive answers. The study of the POSS transients demonstrates how historical data can be reanalyzed with modern techniques to extract new insights. The Palomar photographic plates, now more than 70 years old, continue to reveal secrets when examined with contemporary eyes and advanced computational tools. So which explanation do you prefer? The cool explanation, that we were witnessing genuinely mysterious anomalous phenomena, possibly of unconventional origin, or the more prosaic explanation, that we were simply detecting atmospheric effects from our own nuclear experimentation, disturbing the environment in ways not fully understood? The beauty of science is that we don't have to choose based on preference. We continue investigating, collecting more data, refining analyses, and gradually narrowing the range of possibilities. The truth, whatever it may be, will eventually emerge, and when it does, it will be based on solid evidence, not wishes or biases. The mysterious transients of the Palomar Observatory remain a humble reminder that, despite all our knowledge and technology, there are still phenomena on Earth and in the sky that defy complete explanation, and that, fundamentally, is what makes science so thrilling.